So the table I'm showing now is hot water systems from our national surveys around the country. This is shown from upwards of 200 samples at different temperatures. So at less than 50 degrees you can see that there are low, mean numbers in hot water systems of coliforms and E. coli and heterotrophic plate counts. Heterotrophic plate counts of all bacteria that's everywhere. It's not such a concern. You can see it between 50 and 55 degrees. All coliforms and E. coli are being virtually eliminated from the water supply, and over 60 degrees you've got the same outcome. So the hot water systems at quite low temperatures that are safe for domestic use actually eliminate bacteria from rainwater harvesting systems. This next table I'm showing is a D-value table, which is basically how long it takes to have a log reduction in the amount of bacteria in water. Now the bacteria we're talking about here is not in rainwater harvesting, but we did this work in the laboratory to find out what would happen to common pathogens if they did happen in the unlikely event that they did end up in a rainwater system, and how quickly would they die in your domestic hot water system. So if you can see here, like pneumonia and salmonella, they die very, very quickly at 55 degrees, 19 seconds, 34 seconds. That at 60 degrees, less than 2 seconds, at 6 seconds, 10 seconds. As you can see here, that the pathogens are actually highly susceptible to the temperatures in domestic hot water systems. Basically, they die quickly. So we have a rainwater ecosystem also. So in the natural environment, nature creates a self-supporting system called an ecosystem. In a rainwater harvesting system, in the rainwater storage, it's also an ecology. It's a rainwater ecology with environmental and soil bacteria driving it. These bacteria are harmless to humans. We've identified what they are and how stable they are and how self-regulating they are. What I mean, if some foreign bacteria enters this ecology, like a pathogen, something harmful to humans, it's unusual for this system, and the rainwater ecology acts to eliminate it. So this is a major discovery. It was Craig Evans's PhD with me. So the tanks are dominated by core environmental and soil bacteria. That's the resident ecosystem. Coliforms and other species associated with fecal contamination. It's only a very low number of what we've found in our national rainwater surveys. It's 15% of the total number of species, and we found over 200 species, but it's less than 1.5% of the abundance, of the number. So basically, pathogens are rare and infrequent in rainwater harvesting systems, and they're not abundant, so there's not many of them. So they're not persistent and they're not abundant. And there's a demonstrated mechanism of competitive exclusion. So the good bacteria is destroying the bad bacteria, in lay terms. We also, in our national surveys from all over the country, looked at elements, meaning metals and physical parameters in rainwater harvesting. We found 88% of rainwater was consistent with drinking water guidelines and 93% of mains water. So not all mains water, not all utility water, and not all rainwater was consistent with the guidelines, but most of it was. And you don't exceed the Australian drinking water guidelines unless you've got consistent exceedances. So you have to have 3 or 4 cases in a row of a higher number for, say, lead than the guidelines for you to exceed it. So basically with the rainwater was 100% compliant or close to in this case, because there was no persistent exceedance of the guideline, which is required in Australian drinking water guidelines. So there was small amounts of iron, lead, nickel and zinc that were over the guidelines. For instance, you shouldn't, if you're drinking rainwater, you shouldn't have lead flushing on the roof, for example, because it will actually put some lead in the water. And I've got to the end, so some concluding observations about the rainwater treatment train. Our applied research over 20 years, the carefully monitored demonstration of sites has proved to be vitally important. It has exposed many myths and assumptions about the quality of rainwater supplies, Our findings are consistent with the health surveys that find that people aren't sick from rainwater. Has led to the discovery of the rainwater treatment train. The processes in the rainwater treatment train include flocculation of organic, metallic and chemical contaminants, thereby removing them, as settlement, formation of biofilms and competitive exclusion of bacteria. And biofilms were found in rainwater tanks everywhere. Sometimes you can't see them, but they're there. And they consist of a core group of environmental bacteria such as Bacillus species, which is also in mains water supplies but not measured. Field studies show that bacteria is eliminated by domestic hot water systems at temperatures greater than 52 degrees, so you know, normal temperatures people use in their households. Our laboratory studies show that any pathogens that are unlikely to be in rainwater, but just say if they were, would be rapidly removed from rainwater at temperatures greater than 55 degrees. We also found, these are storage hot water systems, we also found that continuous hot water systems, instantaneous hot water systems, because they apply greater heat energy, were more efficient at killing any bacteria in rainwater. Rainwater tanks function as ecosystems with self-regulatory processes, a natural treatment train, and a first flush device of greater than 20 litres for a normal house roof is inefficient, but having a first flush device of around that size, leaf diverters, and a location of rainwater supply from just above the bottom of the tank, nowhere near the top, was also beneficial from improving your rainwater quality.